Joel, I'm working on 6 different time zones today. And that's the way it's been for the last 2 or 3 weeks. All around the world, we're getting phone calls and Zoom calls, Northern Hemisphere, Southern Hemisphere. It does add up for a small business when you're dealing with so many time zones.
Oh, man, I was thinking before you hopped on here today, and we were talking. I have talked through 4 today, and I thought I was busy, and you're over here with 6 different time zones under your belt, and it's not even dark yet.
Yeah, it's not dark. I still have time. Australia will be calling here in a minute.
There you go. You're up to 7. Lucky number 7.
Number 7, there it is. I think I've set the record, at least for this week.
There you go.
Well, we have a lot of wind energy news this week. The big one in America is that a wind turbine tipped over in Illinois. Why that's a big talking point, I'm not sure, but it is all the rage on LinkedIn, so we'll talk about it. More importantly, Keystone and GE connect on the spiral steel towers, and that's something I have been waiting for a year or two, and I'm just onlooker, but I think that's a really cool project.
We'll jump over to SENSEWind, and we're going to talk about this company coming out of the UK that is doing something like basically a self-erecting tower. Or Alan, during the episode, has his own new term for this tower technology. And then we'll speak about the Netherlands accusing Russia of spying on some of their offshore wind farms. Not sure why or how. Google Earth is your friend to find this stuff out, but the Russians are in that corner of the world peeking around. Also, touching again on some tower technology, we speak a little bit about the first monopile that's on its way to Vineyard Wind off the east coast of the U.S., so that's happening now. And then to close out the episode, our new feature is the wind farm of the week. We're going to talk about the Black Rock Wind Farm in West Virginia and what they're doing over there with the new 5-megawatt Siemens Gamesa machines.
I'm Allen Hall, president of WeatherGuard Lightning Tech, and I'm here with my good friend from Wind Power Lab, Joel Saxum. And the soon-to-be guest host of Fully Charged Live, Rosemary, isn't here today, but she'll be back next week. And this is the Uptime Wind Energy Podcast. Joel, officials for RWE Renewables are investigating what caused one of their wind turbines to fall over at its Pioneer Trail wind farm up in Illinois. The turbine was taken offline earlier because it was leaning. And if you looked on LinkedIn, on social media, you would have seen this turbine pretty much everywhere. And this is the first time, according to RWE, that this has ever happened. And they have 30 plus wind farms across the U.S. and several thousand turbines at this point. That wind farm began operation in 2011, 94 turbines, GE 1.6 megawatt machines. And Joel, the pictures you and I saw on LinkedIn, there was a drone that had gone over top of the site, and it looked like the concrete pad had failed.
When I first saw this thing leaning, I was thinking, man, being deep into the kind of the wind turbine world here, just in the States, but globally as well, you see blade failures and you see generator failures or gearbox failures, but you don't see very many foundation failures. And then I started kind of thinking about it. I'm like, well, I wonder why that is. And kind of like my engineering mind started running, and I was thinking, it's really actually kind of surprising you don't see more of these issues because concrete, mixing concrete and steel and all these different mechanisms together and engineering it in different soil conditions and all this stuff like it. It's a science, right? But it's the same thing as the blades or anything else. When it comes to the engineering world, there's some art to it too, like if you're pouring these foundations in West Texas, it's completely different than if you're pouring them in Illinois with all the organic soils and the different mechanisms of soil movement and all that kind of stuff. And, you get in some areas, Oklahoma regularly has a lot of little, 4.0, 3.0 earthquakes. So it's kind of surprising that you don't see more of these issues with some foundations.
Yeah, it is. And the last time I think we talked about one was up in Canada, probably a year ago. They had they had a turbine tip over, and then they started checking all of the pads, and they had an issue on multiple pads, and they're going to have to repour them, I assume, or try to address them in some way, which would have been an exciting time up there. This situation it seems to be a one-off right now, and the key to this little news story is that it comes at a time when Illinois is in a lot of back and forth between the state officials and the county officials and local officials. The state of Illinois passed a law recently, which basically all the siting and regulation standards for wind turbines and solar facilities are controlled at the state level. So if your local ordinances do not match the state, then the state rules apply. So basically, it took all the power away from the local counties and took it to the state. And that exists everywhere in Illinois except for Chicago and the surrounding area. So that did not go over well with a lot of the officials in Illinois.
It's frustrating, right? Like, so if you've listened to the podcast, I'm from Wisconsin originally. So in Wisconsin, we have kind of the same political, I'm not going to say the same because I don't want to say we're the same as Illinois, but the same kind of like concentrated power as Illinois does, right? So you have the city of Chicago, which Chicago is not even the capital, right? But a lot of the power resides in Chicago. Much like in Wisconsin, a lot of the power resides in Madison or Milwaukee. So you have these couple of strongholds that tend to control or have, their word about everything in the state. Now, if you look at Illinois as a state, where a lot of the rules and regulations and legislation comes from is a very minority position in the state. The rest of it is it's agricultural land. It's conservative people out there that are kind of angry anyways about their lives being run by someone that doesn't have anything to do there. Now, twofold here. So I believe that, when we're talking foundations for wind farms, there is some overarching engineering principles that should be applied, and ASCE or ASCME laws or regulations or guidelines at the state level or even national level for some of these things are okay, right? So, there's things that don't change within this. We know that the reason we put steel in concrete is because the coefficient of thermal expansion of steel is the same as or close to the same as concrete, right? We have these rules around these things and the way they're done, but taking that power away from the local government, I mean, I'm a fan of small government, so I don't really like to see that.
Yeah, and if you're a wind turbine operator, it's a really difficult mix at the moment because there's been a lot of more recent interactions between wind turbine operators and developers and the local officials, and a lot of confusion between the two. And it's hard if you're the developer to navigate all these things because you got local people who probably don't know that much about wind turbine installations, what's all going on, and you have the state that's involved and all their authority, and you're just trying to get a wind turbine project off the ground. It seems like it takes a couple of years to get it done. So I'm assuming that the Illinois legislature decided to make this move because the movement at the local level wasn't where they wanted it. And the way I kind of look at it is it's the United States of America. It's not the United Counties of America. So the state government has a lot of authority over their own state. The problem in some of these areas, like you pointed out, Joel, is kind of like New York, really. New York City and Buffalo control the whole New York state. And it's hard if you're in the middle, which is where the wind turbines are. The wind turbines are not going to be in New York City. They're not going to be necessarily in Buffalo. They're going to be in the middle.
And at some level, because I also agree in I like free market capitalism, right? So RWE, massive international operator, offshore wind farms in Europe, onshore wind farms. They're a German company, right? They've been around forever. They've been around. I think they've been around since the return of the 19th or 20th century. But you have to almost be able to rely on some of their expertise, right? This is, as they have stated here, and as we've stated in watching the market, this isn't a regular thing that happens. This is a kind of a freak event, right? So I believe that they'll do a root cause analysis on this case. I don't think it'll be. From my mind and looking at the pictures, it looks like there's something off there with the concrete. Like there might have been a cold joint or a bad mix or a bad slump in the pour or something at that stage, or some cracks, the freeze thaw level and some water ingress got in there. There's something goofy there. They'll do a root cause analysis study. They'll figure out what it is. They may do some penetrating, penetrating radar NDT test or something on some other foundations and within that wind farm, they'll figure out what the problem is and they'll rectify it. I've got utmost confidence in that. So the people that are saying, well, maybe we need to have more oversight on these things, I think that just slows down our energy transition if you try to do that.
Yeah, I kind of look at it this way. There was the train accident in East Palestine, Ohio, that led to the chemical spill, then the chemical burn, which is one train accident. And when that happened, the response out of the federal government was, well, there's 1,000 train derailments a year. Why is this one any different? Like, okay, that's not a really good answer. In this particular case, it's like the opposite. You have one turbine fall over because of something wrong with the pad, but it was designed such that if something were to happen, it wasn't a safety issue, right? It didn't just immediately fall over. One, and two, it's like there's nothing around it, right? So it's not like that train explosion. I just see they're just wildly different responses. The train was like, ho hum. But the wind turbine was like, oh my gosh, the world is ending. Those don't equate. They don't have to equate, but you just calm down a little bit, right? It's one wind turbine. RWE is going to figure it out. They're going to have this thing identified within the next 2 weeks, probably, if they haven't done it already. And, they're going to move on. Good. That's the way a good engineering company should do.
Yeah, it shows that the wind, that wind energy and the clean energy transition is a bipartisan hot button issue. That's what it shows, right? If you look, you got a cloud of vinyl chloride in the air that you got people that can't return their house because their lungs are burning. And they, oh, no, trains are okay. We'll go back. Like, that's fine. Don't worry about that. And then you have this and there's a big blow up about it. Like it fell into a cornfield or something, right? Like it didn't harm anybody, and it's designed that way. It's not going to fall in a house or fall near anybody. Like you can't site wind turbines that close to buildings anyways.
Right. Which is the point, right? The engineers at RWE wouldn't have let that happen in the first place. They wouldn't put a huge wind turbine next to an apartment complex. That's just not going to happen.
Yeah, I don't want any of the listeners to think that it's not like we're saying this isn't a big deal or anything. Like, yeah, of course it's an issue, right? We're gonna, and as an industry and as a collective and RWE as a company, they're gonna figure it out. I'm sure there's going to be a bunch of subject matter experts involved in this thing, and when issues like this happen, then we dive in as engineers, we learn from them, and we apply the fixes in the future generations. So it's not that it's not a big idea or a big issue. It's just what we're trying to, I guess, communicate around here or talk about is the response to it from the government.
Yeah, which is going to be a success at the end of the day. They're going to figure it out, and it's going to be resolved. All right, so one of my favorite projects over the last year or two has been the people at Keystone Tower Systems and their spiral welded tower, because it is sort of an industry changer. Well, they've been working behind the scenes, and we've asked them to come to the podcast, but evidently they've been too busy. But Keystone Tower Systems and GE Renewable Energy had a milestone with their spiral welded tower, as it was used on a 2.8 megawatt GE machine, a 2.8 127 turbine. And it's a culmination of a multi-year effort between GE and Keystone to design and produce spiral welded towers for GE turbines. The roughly 90-meter tower was manufactured at Keystone's factory in Pampa, Texas. And Joel, Pampa, Texas is up in the panhandle of Texas, which is pretty much as far north as you can get in Texas. And that they hope to create a 200 new manufacturing jobs at that factory when they get to full capacity. Full capacity, they're talking about 1 gigawatt of towers per year. So if they're, it's 200, it's 400 towers a year, roughly. That's a lot of towers to make. And you and I were talking beforehand, Joel, and we thought that the one of the keys to the Keystone effort was that it was going to be a mobile platform, that they could build these towers wherever they were needed. But in this particular case, it's a fixed site, sort of in the central United States. So you think of Texas being pretty far south, but the Panhandle actually is kind of north. It's right next to Texas, Oklahoma, and Kansas. It's right there in the middle of everything. It's probably a smart place for a factory, right?
Yeah, to be honest with you, Pampa, that area of the country near Amarillo and some of those other small, a lot of cotton farmers and stuff up there, like those 200 jobs are going to be amazing for that area. What an economic boom, right? It's huge. And it's not, there's a lot of technical capabilities that go into producing these, but they're not so deep that it's like it's not the aerospace industry, right? Where you got to have all these technical, like highly technical skills. A lot of these jobs will be soaked up like that, so it's great. Another thing about that corner of the world is there's a lot of rail over there too, right? And your Oklahoma's right there, Kansas is right there, eastern Colorado, New Mexico, and yeah, and you've got rail all the way straight shots up to Kansas, Iowa, Nebraska, South Dakota, Minnesota, so Wyoming. I mean, you've got it's a great spot. Plus, like we were talking about, taking advantage of those Texas tax laws, and then right now, great time to build a factory because you can take advantage of ITC. And what as PTC goes, ITC goes as well. So now you're getting some credits back from our tax credits back from our federal government for starting manufacturing jobs in a manufacturing facility in the United States. So we thought it was going to be on site. Maybe it still will. Maybe this will be a staging area. We don't know. But cool to see it happening because we talked about it some months back. This is what they're kind of putting out there as an idea. But now it's reality. They've installed one. It's fantastic.
Yeah, it's good. And Keystone is still working on the mobile factory concept. But Keystone and GE are also collaborating on the GE 3 megawatt turbine platform. And they have signed a multi-year agreement to make spiral towers out of that Pampa factory. There you go. There's a great quote here, and I want to read this quote quickly. Quote, "This collaboration with Keystone is an example of GE's commitment to working with partners to bring new and innovative technology to the wind industry and advance domestic manufacturing," said Vic Abate, GE's renewable energy CEO, onshore wind. "We're delighted to be part of this exciting opportunity for our workhorse products, and with the goal of providing affordable, sustainable, renewable energy to our customers and helping to deliver on the energy transition." So I think the tax implications are pretty clear here, Joel. I mean, GE is going to try to use as many American manufacturers as they can because those credits are in place. So why not?
Thanks to GE for bringing some of those jobs back, right? Like, so we're constantly talking on the podcast here about wanting to see more American companies involved in wind, whether it be from the manufacturing side, the aftermarket side, whatever it may be. So Keystone being one of those new companies, starting up a factory, adding jobs, and bringing some American efforts to the energy transition here is great.
Yeah, as we were talking earlier also, the spiral tower must be a pretty big game changer in either terms of cost of the final tower or speed of manufacturing towers. It's one or the other. GE doesn't tend to mess around with things that are only minor improvements in the way they do business. So this Keystone effort must have some underlying good economics, and GE's going to push it forward. That's great.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
As we stay on the steel tower business, German company EEW Special Pipe Construction, USPC, that's how you'd pronounce it in America. Yeah, sorry, it's totally an American thing. Manufactures offshore wind monopiles and has completed the heaviest monopile for the first commercial offshore wind farm in the U.S., which is Vineyard Wind. The monopile is 1,895 tons of steel for Vineyard Wind 1. And if everybody is not familiar with Vineyard Wind 1, that's located about 15 miles from Martha's Vineyard in Nantucket and about 30 or 40 miles from the mainland of Massachusetts, not very far from us. The comparison that is given in this particular article is a fully loaded 747 is only 447 tons. So basically 4 fully loaded, fully fueled 747s is going to equal the weight of this one monopile. Holy moly. The monopile has a diameter of 9.6 meters and a length of 85 meters. This is a massive piece of steel, Joel. And remember that Vineyard Wind is going to have 62 of these 13 megawatt Haliade X turbines. And it looks like the in December, wait a minute. In December, the first transition pieces were manufactured for Vineyard Wind. So you have the monopile, you have the transition piece, and then you've got the turbine that goes on top of it. But the transition pieces are being made in Spain, being shipped to the United States. And also the cables for this Vineyard Wind project are being made and manufactured and tested in Finland and in Italy. So you got a German monopile, you have a Spanish transition piece, and you have cables from Finland and Italy going into the Vineyard Wind.
And as it sits right now, the blades are being made in Canada. And where are the nacelles coming from?
I don't know. That's a great question. I don't know.
I mean, there's an idea for, of course, GE has put the idea for, up the river there, putting a nacelle factory and a blade factory in New York, which would be fantastic, but that's not ready yet, right? These are happening now. So there's not one major component here that we know of, and maybe we're wrong with the nacelles, but there's not one major component we know of right now that's being manufactured in the US, and that's frustrating.
But that's going to be par for the course for at least the next 2 years, at least.
So I was looking at the size of this thing, and I was talking with my better half here yesterday, and I was looking at the 1,895 ton steel monopile. She's like, "Can you put that into some other context for me?" And I was like, "My truck that sits out in the yard, 630 of those trucks. That's how much it weighs." She was like, "No, yeah, it's dead serious. 630 of those pickups." And now this isn't even the part, like this. The thing here is, this isn't even the part that you'll see. Like, you won't even see this. This is the stuff that's in the water and pounded into the ground. So that doesn't happen. That's not the transition piece when we talk about it is, if you're not familiar with offshore wind, that's basically like the cage that is set on top of the monopile. So it goes, monopile is pounded into the ground. Maybe if you're in 50 meters of water, that monopile might be pounded into the ground another 20. And then the transition piece will sit on top of it. And then the tower sections are put on top of the transition piece, then nacelle spinner blades. So this is it's a lot of work to do this.
So the soil testing around these, Joel, it's going to be interesting, right? When I started reading the numbers, like, man, that's a lot of weight for basically a 10-meter diameter area of ground, right? So you stack all these things on top of one another, and then it has to not sink further into the earth.
Yeah, the geotechnical engineers that work in these offshore wind farms are some of the best in the world, man. A lot of times their design will go, because there's bedrock down there lots, right? So depending on where you are, you might go, say at turbine 4, there might be 3 meters of silt, and then 10 meters of, compacted dirt, and then 4 meters of something else, and then you hit bedrock. So they'll actually measure this thing to go right to bedrock, and they'll set it right on the bedrock so that thing can't sink anymore. And they do a combination. Sometimes it's a combination, sometimes it's individual, of pounding the monopiles, and sometimes they do it with the suction can or at the same time. So if you put the thing into the mud for the monopile, just like a tube, think of like a paper towel tube, stick that into the mud and then cap it, then you can put a water pump on it and basically pump the air and water out of it. And as you do that, it'll suck itself down into the mud. So that's one method of putting in a monopile. The other method is to get on top of it and just boom, 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 jackhammer it down into the mud.
Yeah, I think that's what's happening. The jackhammer is going to be the way that they're going to do it for Vineyard Wind. The question is, how do they know where they're going to bottom out at? How do they figure that out? Do they do core samples? Are they drilling down that far to actually figure out what that depth is?
Oh yeah, a combination of core sampling and near surface seismic. So near surface seismic, think about basically if you were to get an MRI of your knee after having an ACL surgery or something, and then the doctor pulls up the image and you go like, and they kind of slice through it and they go like, see, here is skin, muscle, bone, ligament, blah, 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 blah. Near surface seismic of the seafloor will give you that same profile. And then you compare it with the soil borings or the weight drop borings or whatever in that area to say, okay, this is what we believe is sand, silt, mud, rocks, whatever. Here's the bedrock. So you have that process data of basically acoustic subsurface imaging, which is the near surface seismic, to compare to the geotechnical drilling data. And then that's when they can develop that profile, and then the geotechnical engineers hand it off to the structural engineers, and then they go about their merry way.
So every wind farm in America is going to need to have that survey done.
Absolutely. And a lot of times it will be you'll do, a geotechnical drilling or borings or soil samplings, at along the cable routes. You have to do it as well, but you'll do one big deep sampling at every monopile. And sometimes they also want to do, and this is something not to be missed, they'll also do sometimes an array of geotechnical sampling around each of the monopile locations if they're going to do the installation with a jackup vessel. Because when you're going to install with a jackup vessel, you have to put the legs of the jackup vessel into the seafloor as well. And we've seen that if you don't do that geotechnical exploration properly, you can hit air pockets, gas pockets, soft pockets in the mud, as happened in the South China Sea, and the whole jackup vessel can tip over.
Did they have not only a jackup vessel, but also a monopile tip over? Oh, remember that? That was not very long ago, maybe a year ago.
They lost the monopile. I don't think that wasn't a soil problem. I think they mishandled it. But the jackup, when the jackup went over, it hit a soft spot in the soil. Sometimes you can hit gas pockets or other things like that, or just like where you thought it was sand, but it's actually like, if you've ever walked out into a muddy pond, you'll know when you walk in that stuff, you can be up to your knees. Now imagine you're offshore and that layer that's up to your knees in the pond is 40 feet thick.
So in the oil and gas industry, when they do this work and put these rigs out there, what percentage of them do they have problems with? 1%? Less than 1%?
Less than 1%.
Because they've been there so long in the same basic area?
The oil and gas industry has been doing this offshore work since the 1960s.
Now, how much do we know off the East Coast of America?
Not much. That's the thing, right? So if you go and do this, that's why when we're talking, like right now, there was just another notification coming out today. I saw Bureau of Ocean Energy Management pushing forward on that auction area, lease area down in the Gulf of Mexico. We know what the geotechnics look like in the Gulf of Mexico off the coast of Galveston and Louisiana. We've been out there for years. There's more oil rigs decommissioned on the shoreline than there is in the water, right? They've been there forever. So we know what that sand shelf looks like out to the Gulf, in the Gulf of Mexico, and where there's salt domes and where there's gas pockets and stuff, because we've been all over there. The east coast of the US, we know generally, you can look at geophysically sometimes at the surface, and there's a lot of side scan sonar data and stuff up there, but we don't know the in-depth look at it, right? We haven't been doing that near surface seismic and the geotechnical drilling and all that stuff off of the East Coast because we just never have developed anything out there. So it's expensive, right? It's very expensive. So there hasn't been a reason to do it besides as long as we know what the bathymetry is, so we know what kind of charting is good, and our U.S. Navy can patrol the ridge with our submarines without hitting anything. We're good there, right? So we have a good view of what's there, and by what you see on the subsert, like the seafloor, you can kind of generally know what the subsurface is going to look like. Geotechnically, like a smart geophysicist will know when you look at the mountain ranges in Denver. Well, the front range of Denver, which is or Colorado, the front range, which is all that area behind Denver, behind Colorado Springs, as you go off into the plains, they know that there's going to be oil and gas there because the organic material has been rolled over as those mountains formed and all this stuff. These are things we know, right? So looking at the seafloor, we kind of know what might be out there, but we don't have that granular detail. So now we have to go do all these studies, and it's like I said, it's time consuming, it's expensive. So you're not just going to go do it for fun.
Are we going to hit oil with one of these monopiles, kind of like the Clampets?
No. Now off of the West Coast, that's possible, but off the East Coast, I don't think so.
Well, that explains the Beverly Hillbillies, right?
There you go.
It's the next generation of the Beverly Hillbillies.
I hope that nobody pops into an oil pocket when they're out there doing geotech for offshore wind. That would be a disaster.
That'd be a bad day. Well, Dutch authorities had a press conference recently, and they accused Russia of spying on their assets, quote unquote assets, including the Netherlands offshore wind farms, as part of a broader effort to potentially sabotage European infrastructure. So the Dutch Ministry of Defense and other intelligence agencies, since 2022, have been monitoring Russian ships, and in particular, they want to be really careful around those gas pipelines and any other sort of national resource that could be a target. Uh, this comes on a recent report from the Dutch that they're going to expel 10 Russian diplomats. so, so yeah, yeah, which happens more often than you would think. But they expelled these diplomats, and then it sounds like there's some Russian ships around. They're kind of snooping around, whatever that means. But for several months, the Dutch have been watching Russian vessels, what looks like collecting data on the offshore wind farms off of Netherlands. And other countries have been aware of this too. Norway has seen unauthorized drones near some of its oil platforms. Denmark and the UK have increased security around some of their more sensitive assets. And Joel, you and I talked about this a day or so ago, because I thought it was a little amusing in the sense that Russia knows where your wind turbines are. They're not moving. Any kind of Google search will tell you.
Yeah, I mean, I'm looking at a map of like basically every wind farm in Northern Europe right now that's free. 4C Offshores, that are owned by TGS, is a company. I'm looking at it right now, going like, because I was thinking to myself, I know a couple of wind farms offshore in the Netherlands. I'm like, how many really are there? Pull it up, boom, I can see every single one of them in a free database. Like I don't need to be the KGB to figure this out.
No, it's not good if Russian ships are trolling the area and trying to raise the angst of the whoever Defense Department. That's just not good. But to think that they don't know where the wind turbines are, or if they wanted to knock some wind turbines out, it wouldn't take much to do that. They're just sitting objects. But is this going to be the future, that we're going to have to put barriers around and maybe put perimeters around the wind turbines to say there is no ship entry within these regions? You just can't sail in these waters.
What's to stop it, right? So you can denote this as a government. Do you put a chain link fence in the water?
Mine it?
Yeah, you could mine it, I suppose, but you're introducing so much more risk to the general public. If Russians or anybody wants to sabotage any one of these wind farms, it's not hard, right? It's not very difficult to find where the interconnector cables are. And it's like, okay, so the Nord Stream 2 pipeline that happened 6 months ago, they blew up a pipeline. Now, I'm not saying it was Russians, but basically that was in the news and everybody's like, who did it? Who did it? And then it kind of went quiet. Well, someone launched a missile into the pipeline and blew a 50-meter crater in the seafloor and destroyed a pipeline going into Northern Europe. If someone, I'm saying someone with air quotes, wants to take wind farms offline or anything of the sort, the technology and the capability exists within every navy in the world to go do this tomorrow. There's nothing you can do to stop it besides having your own navy protect your assets at sea. I mean, I hope we never get to that stage. Of we've seen articles and talked about privately, Alan, about some of the different issues we've had in the U.S. around some of our critical energy infrastructure and what has happened, cyber attacks, physical attacks on land. Like this is it may be something that's a specific attack, but it also might be a couple of drunk hillbilly redneck buddies out shooting guns. We don't know. But that stuff can happen no matter where you are. So what's to stop it? I don't know. Mobilizing navies and armies and militaries around the world to protect your own assets. Like I said, I hope we don't get to that. But this article says that they escorted the Russian ship or Russian vessel out of the area. The Dutch Navy did. I don't know. It seems like it should be almost more inflammatory than it has been made up to be. Like, I don't believe that I should just be reading an article on this. This should be something that we hear about at the UN level. Like, this is a bigger problem to me than it's made out to be, I think.
Oh yeah, everybody's trying to keep this tamp down as much as they can. See where it goes. I don't know what you do besides instrument. I mean, I threw out mine as this is a stupid possibility. But you would think that you may be monitoring around them for sure. Why not? You have nothing to lose to monitor.
Okay, so if you're looking at a map, if you're familiar with the North Sea, if it's coming from Russia and it's coming through the Baltic Sea, all of our good friends in Denmark know if a submarine or a ship of any type is coming through there, because they have to basically go through the straits between Copenhagen and Malmo, and I can hit, like, it's shorter than a golf course across. I was going to say I could hit a couple drivers across it, but I can't. Let's be honest. So they could be coming now. If they're coming over the top, any kind of Russian submarine or something's coming over the top along the west coast of Norway and then down, that's a little bit different of a story. But there's so much activity in that North Sea that, you're going to know what's out there. I'm not a naval mastermind, but I don't know. I don't like the situation.
Do you think it changes the way we do offshore wind turbines in America, in the way we defend them?
No, I don't.
You don't think so?
No, I don't, because I think that, contrary to maybe popular belief, if you look at a subsea map of the east coast of the United States, because of what has happened in our past, the Cold War, World War II, all these different things. There has been German U-boats in World War II. There's been Russian submarines during the Cold War, all up and down that Atlantic ridge. I'm not going to say mid-Atlantic ridge. That's a different thing, but that Atlantic cliff, basically, that falls off into the deeper ocean. I know for a fact that the canyons coming up that ridge and that whole ridge are instrumented so well that we as a country, as a military, will know if there's any kind of threat coming up the coast.
I want to tie this into the whale discussion we just had. So we put out a podcast last week talking about the whales on the East Coast. If we can monitor for submarines, can we monitor for whales?
We can. I think so. You just got to put the effort into it.
Are we going to do it?
I don't know, because I think that if you monitor for whales, okay, so now we're going to an ROI, right? So you're monitoring for whales or slowing down the U.S. economy.
Okay. I get you. I totally get you. I get you there. Sure. And
someone's making these decisions somewhere, and that's the two things that you're weighing. You're either shutting down the ports on the East Coast when whales are coming through, or you're saving 430 North Atlantic right whales. Eventually, someone's going to make a business decision.
You're saying to follow the money. What I am saying is, if I knew where they were, then I could maybe slow down if I were around them, if we had the technology to do it. And the question is a submarine make more noise than a whale, or is a whale noisier? I bet the whale is actually the more noisier it makes more noise of the two, probably, right?
I fully agree with, if we can map and know and understand where the whales are, we can put some measures in place. But if the measure is stop all traffic until they clear, it's never going to happen.
Oh, yeah, no. Again, I go back to follow the money, which is a shame, because we should be able to do both, right? We should be able to have shipping and have whales coexist. There's got to be a way to do that. Where we are right now is not going to last much longer, in my opinion.
Ping Monitor is a continuous blade monitoring system which allows wind farm operators to stay ahead of maintenance. Wind techs can often hear damaged blades from the ground, but they can't continuously monitor all the turbines. They also can't calculate how bad the damage is or how fast it's propagating based on sound, but Ping can. Ping's acoustic system is being used on over 600 turbines worldwide. It allows operators to discover damage before it gets expensive and prioritize maintenance needs across their fleet, and it pays for itself the first time it identifies serious damage or saves you from doing an unnecessary visual inspection. Stop flying blind out there. Get Ping's ears on your turbines. Learn more at pingmonitor.co.
SENSEWind, that's spelled capital SENSE, wind, has selected SM Industries to produce a new type of floating wind turbine tower for its flagship 2 megawatt onshore demonstration project. So SENSEWind, if you haven't seen it, has this sort of rail system to assemble towers and then to put the nacelle on top. So it's what they call the first of its kind triple rail. It's interesting. If you can go to SENSEWind, I think it's sensewind.com, and you can see the video there. So they're going to create this onshore project, demonstrate that this self-erecting tower system and the rotor nacelle assembly system will work in practice. So Joel, they assemble the tower in pieces, and they have basically an elevator that's hooked onto these 3 rails that's actually built into the tower itself. So they lift it up, drop a section on, go back down, put another one on, lift it up. So when they get to the top, that's where things get really interesting. So because now you got to put the nacelle and the blades on all at one time. There's really no cranes, no big cranes involved in this tower nacelle assembly. It's like a regular medium-sized crane. So the last bit is they take the nacelle and they kind of hoist it up on the side of the tower, and they horizontally pin in the blades, 1, 2, 3. Okay. At that point, the whole assembly starts crawling up the side of the tower with the nacelle and the blades attached. As it gets to the top, it sort of lifts up. It's kind of like the Viagra of wind tower assembly processes. And it sets this tower right on top. The nacelle goes right on top. That's it. So I'm coining that term, by the way.
The blue pill of
the blue pill of wind turbine assemblies.
I like it. So there's a couple of questions, thoughts here. Now you've thrown me off, but
that's a first, because usually Joel is crushing me somehow with some weird reference.
The one thing the first thing I think about when I watch the video is this capable? Are we able to do this? Okay, the tower could be agnostic. The tower's built by, has a SENSEWind, has the triple tower thing or the triple rail system, but does the nacelle hub spinner blades does that need to be of a specific design as well? Because what I'm worried about is it's tipped. Are we pinching bearings in there? Are we doing anything goofy as it gets moved and swung like that?
That's a good question. Maybe.
I'm not so concerned about the blades, right? The blades or the hub or the actual nacelle, actual nacelle itself. I mean, everything is bolted down in there. If it's tipped 90 degrees, and then that's not a big deal. But I'm worried about we know that there's certain platforms that if you let them sit idle for more than 24 hours, they can end up with divots in the pitch bearing or in the hub bearings, right? So that's how sensitive some of these systems are. So now if you're tipping them 90 degrees and then rotating them through that angular range as you put the nacelle on top of the tower, could that affect the bearings? Does it need to be a special design? Is it a certain kind of can we do this with every turbine, right? Can this be a Vestas whatever, or a V150 or a GE 2.8, or can it be, does it have to be a Nordex N149? What does it have to be? I don't know that. I don't see any materials that tell me that either.
They're looking to finish this first demonstrator project. They're going to start construction at the end of this year and do testing for the following year. So they'll finish up testing at the end of 24. And the whole goal is to get to a 15 megawatt floating offshore wind assembly project. That's where it's going. In a sense, to make the ship's cranes smaller, non-existent, and maybe it's a good idea. Yeah. On shore, I don't think this makes a lot of difference, right? That you have cranes that are available. Everybody knows how to do that. Offshore, a little bit different. This may be a really interesting development for offshore because it would, in theory, maybe drastically lower the cost of an installation.
The fun thing to track here, Alan, is that we talked about offline as well as, we were talking the other week about blade robots and how there is, at what level will one of them become, the class of the industry, kind of like what happened with autonomous drone inspections. Now, in the last 6 months, we've seen a bunch of these different kind of solutions come out from, we have like the lift works. There's this company, that company. There's SENSEWind. So there's all these kind of different designs, and everybody's playing around with these. So will one of them become the class of the market, or will it be? It's not as transportable, right? Like when drone inspections came out, it's easy to throw a drone in a Pelican case, get a car net for it, and jump across borders and inspect turbines all over the world. A piece of equipment like this, or something specialized as far as a lift, may be more geographically limited. Based on where you are, where you're developed. Like if you develop in the UK, you're probably going to be working in the UK for a while before you've got it really nailed down before you export it to other countries and whatnot. So interesting to see who starts soaking up some market share here from the classical crane companies with these different solutions.
Well, it feels like you need SpaceX kind of money to do a project like this? You're talking about re-engineering a good part of the way the wind turbines are built, which is what SpaceX did, right? SpaceX tossed out the conventional rocket concept and built their own and launched it the way they wanted to launch it and landed it the way they wanted to land it. Now we're talking about assembling wind turbines in a particular way to save in the overall cost. That's a great idea. It's just, do you have the funding to get the project to the end? And a 15 megawatt turbine is a very expensive item to be playing with. Is it worth the risk? I think it's the risk calculation. If you're not spending your own money to evaluate that risk, you may not get a lot of OEMs that want to play along in that.
Yeah. So if you look at who SENSEWind has kind of on board, I know quite a few of these companies. Have either worked with them or know people, decision makers at them. So Holder Marine is out of Aberdeen. Creatus, I know, out of Denmark. Exodus is a great renewables consulting company. The ORE Catapult is involved. Subsea Micropiles, I know a whole bunch of their senior leadership team, but I don't see where they fit into this as much. But some of the funding is coming from Innovate UK, Carbon Trust, Department for Business, Energy and Industrial Strategy. There's some federal money behind this thing too. So good job on raising cash.
It's a great idea. And I think if implemented, it could work. It's just in this weird economic environment that we're in at the moment, where in the US, the Federal Reserve keeps ratcheting up interest rates. It's going to be hard to fundraise for a project like this worldwide. When the US does it, it hurts.
The difference here is a lot of their funding is coming from the federal government of the UK rather than private industry.
It's one to watch, and I think they have the right team. I was on their website. I've been on the website a couple of times now. They have the right people. That appears to be in place. It's just a question of the economics, right? And part of any business is timing. Everybody will tell you. You could have the greatest idea at the wrong time, and it just doesn't work out. They have a really good idea. It's just that the economy isn't going to be on their side at the moment. Maybe it will in another year, and by 2024, they get this thing figured out. They get a demonstrator working, and boom, it just explodes because they have the right concept.
Yeah, the tough thing there is, as well as I've been involved in innovation for a lot of my career, is getting that person, that one decision maker, to take a leap of faith and use you. Right. So like you said, if they're looking at some developers looking at an offshore wind farm and the cost is going to be $1 billion, but that $1 billion turns into 800 million by using this, is $200 million worth the risk of failure. That's the problem, right? Because you still have to have a jack. Like if you're going to put this out there, you still almost need to have a jackup vessel and cranes and stuff at the ready in case it doesn't work. That's the way a lot of these programs work. So, but it has that possibility, right? It has that possibility of really reducing the cost of installation. So, hope it works. I like it.
I hope so too. I hope it does work. Our wind farm of the week is Black Rock Wind Farm in West Virginia. That's a farm operated by Clearway Energy Group, and it began operation in 2022. One of the unique things about this wind farm, it has 23 Siemens Gamesa wind turbines, the SG 5.0 145s. Those are big wind turbines for onshore project. BlackRock created 200 union jobs and 12 permanent operations jobs. And they're doing a lot of things in the community. Clearway is here. They've been hiring graduates from the local community college and technical college, and recruiting locally, of course. And they set up a BlackRock Community Benefit Fund, which donates $50,000 to local nonprofits each year. And as part of this project, obviously, they're going to pay taxes. So Clearway will pay about $15 million in taxes to the state of West Virginia for the life of the project. The power is delivered to AEP Energy and Toyota Motor Sales USA. So they got some PPAs in place. Nice job, everybody. Interesting project for West Virginia. There's more to come, but congratulations to Clearway Energy Group, our Black Rock Wind Farm, our wind farm of the week. That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. please give us a 5-star rating on your podcast platform and subscribe in the show notes below to Uptime Tech News, our weekly newsletter. And check out Rosemary's YouTube channel, Engineering with Rosie, and we'll see you here next week on the Uptime Wind Energy Podcast.